Welcome back to another lesson in MCR3U. Today we'll be talking about Introduction to Functions, Relations, Domain, and Range. So let's start with a few definitions here. So when we think about a relation is identified pattern between two variables. It may be represented as a few things, as ordered pairs, table of values, a graph, or an equation. When we think about domain, we often think about the x values. Domain is the set of the first coordinates, usually the x values, of the ordered pairs in a relation. When we think about the range, we often think about the y values. And the range is the set of coordinates, usually the y, of the ordered pairs in a relation. So it's important to distinguish between a function and a relation. So a function is a relation in which for each value of the independent variable, so important here, for each value of the independent variable or the x coordinate, there's exactly one value of the dependent variable. And one way to determine, again, if something is a function versus a relation is to use a vertical line test. And so that's a visual representation. And it's a method of determining whether a relation is a function if every vertical line intersects the graph at once. Then the relation is a function. So here, it's important to understand that all functions are relations, but not all relations are functions. So when we model relations, there's again a few ways that we mentioned above to look at it. Again, there's tables so with an x5 value, x coordinates, y coordinates. There's ordered pairs, there's mappings, there's graphs, and there's equations. And what we can notice here is, again, if we have an ordered pair, for example, you can always change it into another way to model it. So here, for example, if we have an ordered pair, we could easily convert it in terms of its xy values to a table. And same thing with these mapping notations. So here we have -7 and 2, so we can easily change them into ordered pairs. -7, 2, 0 and 2, and 3 and 1. And we can do that with all the other ones as well. It's just showing that there's so many different ways to model the relations, and they're always interchangeable, and you can always use them to help you represent them the best way that it shows. And so here, when we're testing for functions, again, if there's the first way is using an algebraic way or algebraic test. So if a relation is given as an equation and the substitution of any value for x results in one and only one value of y, then the relation is a function. So that's important here. Any value of x results in one and only one value of y. Then again, the relation is a function. So here, there's y is equal to 3x minus 1 is a function. As for any value of x, there's only one corresponding y value. And we know that that would be a linear line here. So we know that that would hold to be true if I drew a graph here. So it looks something like this. And we see that for every x value, there's only one y value. Here we have x is equal to y squared is not a function, since if x is equal to 4, then y is equal to plus or minus 2. So here if we show that, we have square root 4. No, sorry, 4 is equal. So x is equal to 4 is equal to y squared. Here if we square root both sides, we see that y would be equal to plus or minus 2. And therefore, there's points at 4 and 2 and 4 and -2. And so for any value of x, there's not just one value of y, there's two values of y in this situation. The next way to test again if something is a function is by using the vertical line test where we mentioned above. And so how the vertical line test works is that if we draw all possible vertical lines on a graph of a relation, the relation is a function if each line cuts the graph no more than once. It's not a function if at least one line cut the graph more than once. So here, if we look at these examples, we're indicating again which ones are functions and which ones are relations. So if I take this line here, I move it left to right. Okay, so let's look at this one first, and we'll draw one for each. So here, as I move it from left to right, we see here that it passes the vertical line test because it doesn't pass through multiple points. So here, we'll just draw this line here and we'll keep it here. For B, and here, if I draw a line through, and move it left and right, you see that again, it only passes through one point as well. Okay, so here for A and B, A is a function, B is also a function. Let's look at C. So C, if I draw a line here as well, draw a line, if I move it left and right, we see here that it still, again, will only pass through one point here as well. So here, this is also a function. Now let's look at D here. So if I draw a line through, we see there's multiple points where it passes through more than just one point here. So here, if I look at this point right here, it passes through this point and this point. So here it fails the vertical line test, which means that this would be a relation. And then let's continue on with these ones. So I'm not going to move the line each time, but here we see that this one passed the vertical line test, which means that it's a function. This will fail the vertical line test, which means it's a relation. This will pass the vertical line test, which means it's a function. Here, what you'll notice is there's one point right here that fails the vertical line test because it crosses through these 2 points. And so it fails the vertical line test right there, and it only needs one spot where it fails the vertical line test for it to become a relation. And then last one here. This is the vertical line test again, so this is a function. And here it says, for which of the following functions, which of the following are functions? So here y is equal to 2x plus 1. And so here, this one is a function. Again, for every x value, there is a different y value. So look at b here, put into a table values, what I'd like to do just to make it easier for us to visualize. So we have 1, 3, 1, 4, 1, 5, and 1, 6. And so here, and here it's the same x values, but multiple y values. And if we put that in a graph, this is what it would look like. Let's put it in a graph, and at 1, it would be at 3, 4, 5, 6. And so that clearly would fail the vertical line test. And so here, last one, this should be C. So if we put in a table of values again, so we have 3 and 1, 4 and 1, 5 and 1, and 6 and 1. And so here, there's different y values, sorry, different x values, but same y values. And that still means that it is a function, because if you look at the graph, it would pass the vertical line test, because here, be x is equal to 3, y is equal to 1, x is equal to 4, y is equal to 1, 5, 6. And so here, if you drew a line, here it would pass the vertical line test. And so here, again, for B, this is a relation, and for C, this is a function. And so when we look at, and when we continue on here, we're going to look at what is called function notation. And here, this notation might seem be new to some of you. And here it's noted as function notation, and this is f of x. That's how we say it, f of x here. And this is the output value. So this is the output value. The x is the name of the function, and any letter can be used. And then the square root x plus x squared plus 1 here, this would be the square root is so the rules that tells you what to do with the input value in order to produce the corresponding output value, and the x here is the input value. So here, how we would say this is f of x is equal to square root x squared plus 1. And so it's a function in terms of x. And so this is a function in terms of x. And so again, don't confuse f of x with multiplication. Again, the entire symbol f of x represents a function, its input, and its output. Again, here it's not the same as an algebraic expression. And so here, if we're given f of x is equal to 2x plus 3, telling us to find f of 6. And what that means is wherever x is in our function, we're going to sub it in for 6. So here we have 2 times 6 plus 3 is equal to 12 plus 3 is equal to 15. Here, wherever x is, we're going to sub in. We're going to sub in -5, so 2 times -5 plus 3, which is equal to -10 plus 3 equal to -7. Here, for every value that is x, we're going to sub in w plus 1. Here will be 2w plus 1 plus 3. I'm going to distribute the 2 into the w and to the 1. So here we'll get 2w plus 2 plus 3 is equal to 2w plus 5. And here, again, for every x, wherever the x values are, we're going to sub in 2x. So here we'll get 2 times 2x plus 3, which is equal to 4x plus 3. And just kind of bonus question here. If f of x is equal to x squared plus x, find f of x plus 3. So remember, for the x value, we're subbing this entire thing in. So f of x will be equal to x plus 3 squared plus x plus 3. Now here we have to make sure we can we can take out the x plus 3 as a common factor, and we're left with x plus 3 plus 1, which is equal to x plus 3 and x plus